Well, we want to deal with the topic of probabilities. Now, and we will start with the simplest case, when we are dealing with so-called Laplace experiments. And for that, I would like to briefly explain what a Laplace experiment is. This is a random experiment, as we saw in the last video, which means it has the following additional properties. On one hand, there are only finitely many possible outcomes, so our omega consists of only finitely many possibilities. However, this does not have to be the case, as omega can also actually be infinite, meaning there are only finitely many cases. And the second property is that we assume that all these outcomes are equally likely. And now you can see it's not quite so trivial what that means, but we assume that there is no preferred outcome. And exactly examples of this are precisely the mentioned dice throws or coin tosses, provided they are fair. This is also called a fair coin toss, when both heads and tails have a probability of 0.5, meaning they are equally likely at 0.5. We will discuss shortly why this is the case. So this is a Laplace experiment. And for such a Laplace experiment, we can relatively easily provide probabilities for these outcomes. So let's imagine we have such a Laplace experiment and we have n possible outcomes, which means our omega consists of n elements. I think this is very logical and clear for everyone. Then we want to define a probability for each outcome. And this probability is 1 divided by n. If there are n possibilities, then the probability of an outcome occurring is 1 divided by 0.5. In the case of a dice throw, it is 1/6, and for a coin toss, it is 1/2. And it is even simpler when we have an event now, because what we want to do is assign a probability to each event, that is, to each subset of omega. And let's imagine that the event occurs in k of these cases, which means that our A consists of k elements. Then we can also simply state what the probability is that A occurs, namely, you will not be surprised to hear Kn. So Kn is the probability that event A occurs. Yes, so far so good. This is, so to speak, the simplest possible case, and they probably knew that. In the next video, we want to introduce probability theory in a more general way, meaning that we no longer need the property that everything is equally likely. Instead, we want to choose an axiomatic approach to probability. But more on that in the next video.